Let's work on using long division to divide 12x squared plus x minus 4 by 3x minus 2. We will set up division just like the usual division of numbers. So we are dividing 12x squared plus x minus 4 by 3x minus 2. But what we focus on leading coefficients, and the leading coefficient here is 12x squared, the leading coefficient here is 3x. We'll go ahead and divide 12x squared by 3x, and after all the cancellations we get 4x. That's the first term in the quotient. After that we take 4x and multiply it by 3x minus 2. And once we distribute, we get 12x squared minus 8x, and that gets below the polynomial we want to divide. And we're going to start subtracting. 12x squared minus 12x squared disappears, and then x minus 8x is a bit complicated, so I'll work it out on a side. We have 12x squared plus x minus 12x squared minus 8x. Distribute to the negative, you get 12x squared plus x minus 12x squared plus 8x. All of that comes out to be 9x. So we have just 9x here. And then this negative 4 gets carried over. Again, we focus on the leading coefficients, and it's 9x divided by 3x. All of that works out to be 3. So plus 3 is the next term in the quotient. Then we multiply 3 by 3x minus 2, and we get 9x minus 6. So 9x minus 6 goes below that term, and we get another subtraction going on. 9x minus 4 subtracted 9x minus 6, distribute to the negative, and we get 9x minus 4 minus 9x plus 6. All of that is 2. So we get 2 as the remainder. So let me state the result once again. Quotient is 4x plus 3. The remainder is exactly 2. And we can write the original polynomial, 12x squared plus x minus 4, being exactly equal to 3x minus 2 times 4x plus 3 plus 2. So the last term is the remainder, and the 4x plus 3 is the quotient, just like with the whole numbers. Let's work on another example. Let's divide this 5th degree polynomial by 2x cubed plus 1. So we set this up as the long division. Then we focus on the leading terms. We have 2x to the 5th divided by 2x cubed. So 2 divided by 2 cancels, x to the 5th divided by x cubed is x squared. That's the first term in the quotient. Then multiply x squared by 2x cubed plus 1. So we get 2x to the 5th plus x squared. All of that goes below the polynomial. Now I will align the 5th degree term and the 2nd degree term, so that it's easy to do subtraction. 2x to the 5th minus 2x to the 5th cancels out. X squared minus x squared cancels out as well. So all that is left is negative 8x to the 4th plus 2x cubed. Now again we focus on the leading terms. Divide negative 8x to the 4th by 2x cubed. All that we get is negative 4x. So negative 4x is the new term in the quotient. Then multiply negative 4x by 2x cubed plus 1. We arrive at negative 8x to the 4th minus 4x. That goes below this term. And again I'm gonna align the terms with various powers. Since 4x is not x cubed term, I'll put it to the side. We have negative 8x to the 4th minus negative 8x to the 4th, all of that disappears, and we're left with 2x cubed, and minus negative 4x gives us positive 4x. Now again, focus on the leading terms, so we'll look on 2x cubed and 2x cubed there. and their quotient is exactly 1, so that's the last term in the quotient, positive 1. Then we multiply 1 by 2x cubed plus 1, we get 2x cubed plus 1. So we put 2x cubed here, plus 1 there, and after we do all the subtractions, we end up with 4x minus 1. Now this is going to be the remainder because 4x is lower degree than 2x cubed. So quotient is x squared minus 4x plus 1. Remainder is 4x minus 1. And the original polynomial, 2x to the fifth minus 8x to the fourth plus 2x cubed plus x squared, could be written as 2x cubed plus 1 multiplied by x squared minus 4x plus 1. All of that added for x minus 1. So the last term is the remainder, and the second term there is the quotient. Now let's work on using long division to divide 4x cubed minus 3x squared plus 3x minus 1 by x minus 1. So let's see. We look on the leading terms, and 4x cubed divided by x is 4x squared. That's the first term of the quotient. Then multiply 4x squared by x minus 1, that gives us 4x cubed minus 4x squared. So put 4x cubed minus 4x squared below and do the subtraction. And it's easy to do it on a side, so I'll have 4x cubed minus 3x squared subtracted 4x cubed minus 4x squared. So we have 4x cubed minus 3x squared minus 4x cubed plus 4x squared. All of that boils down to a single x squared. That's what is left. Carry 3x over. Then again focus on the leading terms, so we divide x squared by x and we end up with x. That's a new term in the quotient, plus x. Then we multiply x by x minus 1, we get x squared minus x. So we put x squared minus x below and do the subtraction. Since it's kind of tricky, we do it on a side, x squared plus 3x minus x squared minus x. So it's x squared plus 3x minus x squared plus x. All of that boils down to 4x. So 4x gets here, and then we carry negative 1 over. Now we divide 4x by x, get a positive form. That's the last term in the quotient, plus 4. And then multiply 4 by x minus 1, it's 4x minus 4. So we subtract 4x minus 4 here, and doing it on the side, 4x minus 1 subtracted 4x minus 4 is 4x minus 1 minus 4x plus 4. All of that boils down to positive 3. So that's the remainder in our division. And we have that the quotient is 4x squared plus x plus 4. And the remainder is positive 3. And then the original polynomial could be written as 4x cubed minus 3x squared plus 3x minus 1. That's the original polynomial. It is equal to x minus 1 times 4x squared plus x plus 4 plus 3. And this 3 is the remainder, and 4x squared plus x plus 4 is the quotient.